This is a regression analysis question for predictor variable being grant scholarship and the dependent variable being the total loan debt at graduation. Now, I want to just point out one small thing which is not really needed for solving this question, but some of you may have noticed. Here the value 38672 is different from 38672.04, and the reason is that when the Excel table was made, the values were inputted so that it's given in the units of thousands of dollars. So see, this 38.672 really means 38.672K, which is same as $38672. Okay, but that was just a small remark. Let's move on to the very first question. Determine if there is a significant linear relationship between the variables by the road test. I should have given the significance level. If it's not given, just think of it as 0.05. That's the typical significance level people use. And the important thing is, for road test, it's a test on the value of R. Our value of R is 0.712. So you need this value, and there's another value you need for the road test, which is the DF, degrees of freedom. And degrees of freedom is n minus 2 for linear regression, simple linear regression. And since our n is 8, see, the data is from 8, so that's your value of n. 8 minus 2 would be 6. So 6 is the degrees of freedom. Now, in multiple regressions setting, the formula for degrees of freedom of the residual, it's called, is n minus 1 minus k, where k is the number of predictor variables. In our case, we just have a single grant scholarship aid value as the predictor variable, so k is just 1. So this is the degrees of freedom for the residual in multiple regression. So you might want to memorize this one as well as this one in the case of simple linear regression. All right, so once you have these values, you need the row table, which will be given to you if you're taking an exam, or if not, you will have to, if it's not an exam situation, then you'll have to, if you're doing a homework on this, you'll need the row table, and it's something like this. And in our case, at 0.05 significance level with degrees of freedom 6, you see where they meet. They meet at 0.7067. 0.7067. So critical row is 0. Forgot it already. Sorry, 7067. Right. And since R equal to 0.712 is bigger than 0.7067, remember that if the R value is closer to 1 or closer to -1, it's more correlated. So in other words, the regression analysis gave us more correlation than the correlation level where we would deem it as correlated, right? So since this value is bigger than 0.7067, we know that there's a correlation. So there is a correlation. Or another way to say it is that there is a significant linear relationship. Okay, there is a significant linear relationship. Okay, now let's move on. Based on the results from part A, what is the predicted debt of a student with 17,500 and grant scholarship aid. Okay. So it says based on the results in part A, and the reason they say it is because if the correlation is not significant, then instead of using the regression equation, you have to resort to the average value. Okay, so it's this value. Okay, so if this came out as not significant linear relationship, then you would be using 46410 as your best predictor. However, because our regression equation came out significant, we now have to use this value to predict. So let's copy this here, and then let's paste it here. Okay. And we are going to use a calculator to put these numbers in, and that's all we need to do. Okay. So let's see. It's 38672.04 plus 2.08 times 17,500. Enter, and 75072.04 is the value. Okay, 75072.04 is the value. Okay. Okay, what percent of variation in debt is unexplained by the regression equation? Well, for this question, you have to remember that r squared gives you the percent of variation explained by the regression equation, and therefore we can calculate r squared from r being 0.7712, right? So let's take that one, 0.712, and we'll square that one, enter, and we get 0.5069 or 507, 0.507, which is 50.7%. But if you look at the question, it says what percent of variation in debt is unexplained. So that means you have to subtract from 100%, 50.7%, and that gives you 49.3%. So the answer is that this much is unexplained by the regression equation. Okay, now construct a 98% confidence interval for the true coefficient of grant scholarship aid. And the confidence interval for a variable, the coefficient, is given as bi plus or minus t alpha over 2, and then the standard deviation of that variable. So you first have to know this formula, and we have to go back to this table here and see that the coefficient value is 2.08. That's your B1. This is your B1. Okay, and this one here is your S of B1. So we have both the values for this B1 and SB1. So the only thing that's missing is T alpha over 2. So how do we get that? Well, so for the critical value in T distribution, you need to first find the alpha level, which is 1 minus the confidence level, which is 0.98. And then to get the critical value, T alpha over 2, you need to use the calculator with inverse T of 1 minus alpha over 2. And you need to provide the degrees of freedom, and our degrees of freedom a moment ago was 6, right? So that's what you have to do. Let's see, alpha is 0.02, so let's use our calculator to find that value. So second vars, you go to inverse T, and you do 1 minus 0.02 divided by 2, and then degrees of freedom will be 6, and then you press enter, and the value is 3.14266. So we can say 3.143. Okay, so now we have everything. 2.08 was our B1 plus minus 3.143 times 0.38838, 0.838, and let's actually calculate both of them. So first we're going to do 2.08 plus 3.143 times 0.838, and that's 4.714. Okay, and then for the other one, 2.08 minus 3.143 times 0.838, and this is negative 0.553834. Okay, so that's the 98% confidence interval. It's from negative 0.554 until 4.714. Okay, so that's the answer.